Hi everyone, welcome to section 9-2b, graphing quadratic. So graphing quadratic inequalities is going to look a lot like graphing quadratic equation. We've got a couple extra steps at the end that we need to make sure that we finish since it's an inequality and not an equation. So it's going to sound very familiar. So notice our equation, or our inequality, I guess, if I'm being technical here. I've got the same A's, B's, and C's. It's in standard form. It's not in vertex form, but it could be. We could do the same thing if it were in vertex form. But in this particular case, I've got a y is less than ax squared plus bx plus c. I could have a less than or equal to, greater than or equal to, any of the above. So how do you graph a quadratic inequality? Well, you might be surprised that you start with the vertical axis of symmetry on the graph. And what was that equation for axis of symmetry? X equals, everybody's got that memorized, right? Negative b over 2a. Well, negative b over 2a is the same equation we used when it was just an equation, not an inequality, and the a and the b come from the same place. Next, you're going to find your vertex and get that on the graph. Remember, this is a point xy on the axis of symmetry, and we find that by putting the x value from our axis of symmetry into the inequality and figuring out what value we get. You kind of ignore the inequality and just think of it as an equal sign because we need an actual value. So use an equal sign while you're finishing up the vertex. Next, plot your y-intercept. Just like always, where does the y-intercept come from? It's our c value. And if you wanted to, you could use this, the y-intercept as well as the mirror image point. I'm going to say all the same things that I said for graphing a regular quadratic. You need to have 5 ordered pairs. So we've got a vertex, we've got a y-intercept, we've got a mirror image point. Next up, we'll put the solutions, remember, to solve or not to solve. And I could do this like I did before. To solve or not. So what's your alternative if you don't want to solve or you can't figure out what multiplies a times c and adds to b? Your alternative, instead of solving, plotting the solutions as the x-intercepts, is to use an xy value table. I want you to have 5 points, put the vertex in the middle, count 2 up and 2 down, and plug those into the inequality. Treat it like an equation to get those values. So everything has been exactly the same as a quadratic equation. Here, steps 6 and 7 are the only 2 things that change. So just like when we were doing other things, when we were doing inequalities, linear inequalities, we're going to decide if your parabola should be dashed or solid. So you're going to use a dashed line if it's less than or greater than. You're going to use a solid line if it's less than or equal to, or greater than or equal to. So before you do that, maybe even way at the beginning, you write down dashed or solid so that if you're in a rush, you can make sure that you get that information and you remember to do dashed or solid. And just like we did with linear inequalities, your last step is to test a point. And you're actually going to shade either inside the parabola or around the outside of the parabola. What is the easiest point to test? Use 0, 0 if possible. If the parabola touches 0, 0, you are not allowed to use that because it's not going to give you good enough information. So find an alternative, 1, 1, or 3, -2, or something. But if you can, use 0, 0. If your vertex is 0, 0, you can't use it. So if the parabola touches 0, 0, you're not allowed to use that ordered pair to test. And then we'll actually shade for our last step. So let's do an example. Let's start out with the equation. Y is greater than or equal to -3x squared plus 1. So we have a couple options here. This is actually in vertex form if you want to think of it in vertex form, Or this is actually also in standard form. If we're going to do our axis of symmetry, we'd have to identify our A, B, and C, right? So what's our A value in this? -3. B is 0 because C is 1. So if I'm going to do x equals negative b over 2a, somebody asked me when we were doing the activity, yes, if your b value is 0, that means your axis of symmetry will be 0 because it would be -0 over -6, which is a big old 0. That also means our vertex is at 0 something. Now you might have seen that this is already in vertex form, and you might have noticed that it would shift left and right, not at all, but it would shift up 1 on the y-axis. So if I plug in a 0, or if I see it as vertex form, my parabola's vertex will be at 0, 1. Y-intercept, not a lot of good information here. Also at 1 because that's my C value. And solutions, do you want to solve it or do you want to make an XY table? I'm going to make an XY table. So I'm going to put 0, 1 in the middle, count down, and count up. Remember, our domain is all reals. You could use any numbers you want. But I always like to pick ones that are easy to get so that we have that mirror image. So if I put a -2 in here, -2 squared is +4. So -3 times 4 is -12. Plus 1 gives me a -11. If I put a -1 in here, -1 squared is +1 times -3 is -3. Plus 1 is -2. If I put a +1 in there, I should get the same value that I just got. So +1 squared is 1 times -3 is -3. Plus 1 is -2. And last but not least, when I put a 2 in there, I've got a 2 squared is 4 times -3 is -12 plus 11, or plus 1 is -11. So let's get these points on here. Before I do that, am I going to use a solid or a dashed line when I actually connect these points and make a parabola? Okay, solid line. I don't want to forget that steps 6 and 7. So my vertex is at over 0, up 1. I've got an ordered pair at -1, -2. -2, -11 falls right off my graph. +1, -2. My mirror image, I should have put that axis of symmetry on there. Notice that -3 tells us the parabola is going to open down. It also tells bigger numbers, skinnier graph. So I'm going to have a really skinnier graph compared to my parent graph. It looks pretty skinny to me. I'm going to use a solid line to connect them. It's a quite skinny graph. So I've got my parabola. I know it's connected with a solid line. And now I'm going to do the last step, which is shading. Does my parabola touch 0, 0? Can I use 0, 0? I can, right? Because my vertex is at 0, 1. And it's kind of hard to see on here. But 0, 0 really is right in the middle of that parabola. So if I test 0, 0, I'm going to put a 0 in for the y. Actually, why don't I just write this and then we can put those in there. So y is less than or equal to -3x squared plus 1. When I put a 0 in for the y, a 0 in for the x, so 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1, true or false? That's true, right? 0 is less than 1. It's not equal to, but it's an or. So this is a true statement. So that means I want to shade where 0, 0 is because I got a true. So I want 0, 0 to be shaded. So I'm going to shade inside this skinny parabola. So let's skip 2. Let's do graph 3. Graph and shade. Y is less than 1/2 x squared plus 2. So this actually also is already in vertex form. Let's look at it like that. So y is less than ax minus h squared plus k. So where's my vertex going to be? What number is inside the parentheses with the x? Nothing, right? So that's going to be a 0. And what is my shift up or down at the end? That would be a 2. So my vertex is at 0, 2. This time, instead of saying, oh, we found our axis of symmetry, so we're going to repeat it in the x value of the vertex, now we're going to say, oh, we found the x value of our vertex, so I know my axis of symmetry is the same. So it's going to be a dashed line right on top of the y-axis. I know because my 1/2 is positive that it's going to open up, and I also know it's a small number, so it's going to be a wider graph. So I've got that information from vertex form. Y-intercept is also going to be 2, because this really is my c value. If I have parentheses around that x minus h, then I can't just see my y-intercept so easily. If you want to go back and do negative b over 2a to find that axis of symmetry, go ahead and do so. You will end up with the same answer. So I'm going to make an xy table. I don't have a whole lot of points. All I have is my vertex at 0, 2. That point right there, and that's also my y-intercept, so it's the same thing. So I'm going to put 0, 2 in the middle, a -1, -2, +1, +2. Let's do some quick math. It requires fractions, but that's all right. So when I do -2 squared, I get a 4. 4 times 1/2 is 2. 2 plus 2 is 4. If I put a -1 in there, -1 squared is 1. 1 times that 1/2 is 1/2. 1/2 plus 2 is 2.5 or 2.5. I already know what I should get when I put a 1 in that spot, but 1 squared is 1 times 1/2 is 1/2 plus 2 gives me another 2.5. And when I put that 2 in there, 2 squared is 4, 1/2 of 4 is 2, plus the 2 at the end is 4. When I put these dots on my graph and I connect them, am I going to use a solid or a dashed line? Solid or dashed parabola, right? That will be dashed because it's just a less than. It's not an or equal to. So I've got my vertex already on the graph, -2, 4, and +2, 4, and -1, 2.5, pretty close together, but I can make them fit. And remember, the graph should be pretty wide. Oh, and I forgot to make it dashed. Erase that or put a line. Gosh, here I was talking about making it dashed and then I forgot. So I'm going to make myself a dashed parabola. Don't forget your arrows at the top. So now I'm going to test a point because I have to remember to shade. So is 0, 0 okay to test? Parabola doesn't touch it, right? So test 0, 0. So my original equality is y is less than 1/2 x squared plus 2. So I'm going to put 0 in for y and 0 in for x. So 0 is less than, 0 squared is 0 times 1/2 is 0. 0 is less than 2. Well, this one came out true. That's true, right? 0 really is less than 2. So that means that I want the part that includes 0, 0 to be shaded. So will that be inside or outside of the parabola? I want 0, 0 to be shaded, so this one's going to end up, even though I got a true, this one's going to end up being shaded outside that parabola because I want my point 0, 0 to be in the shaded area because I got a true statement. So it's not about inside or outside the parabola, it's whether 0, 0 gets shaded or not shaded. All right, we'll save problem number 2. We'll do that one together in class. Really quickly, explain in your own words how you know where to shade a quadratic inequality. Explain what we just did, whether we shade inside or outside the parabola. Explain what we did in order to do that. I want to make sure that you understand the shading process, basically. And practice problem is not problem number 2. I'm going to ask you a couple questions. If you graphed that parabola, y is greater than or equal to -1/2 x squared minus x plus 3, would the parabola be a dashed or a solid line, and why? And then if you use that same inequality to test 0, 0, do you get a true or a false? Do you want 0, 0 to be shaded or not shaded? So I'm not asking you to graph anything for the practice problem, just know what to do to get those things in there. That is the end of section 9.2b. Have a great day.